All right, so I thought it'd be good to go through a video explaining how lines in 3D space can be oriented and whether they intersect or whether they're parallel and all that sort of stuff. So, lines in 3D space basically have four options. The first one we're going to look at is when they're coincident, which means that they're parallel and they're not distinct. So, that basically means the lines are the same line, they're just two lines sitting on top of each other. The other option you can have is that they're parallel and distinct. So, they're just two parallel lines in space, never touch. You can have the option where they intersect at a point. And the final option, which is only possible in three dimensions, is that they're skew lines, so that they're not parallel, but they don't intersect. So similar to two dimensions, except this extra additional situation here. So what you'll notice here in the 3D view, we're going to look at coincident lines, is you'll see that these vectors basically define some line. So this point P is going to trace out a line, and this other point down here, this green point, is going to trace out a line. We're going to see that those lines are actually the same line. So let's do that. The way I've defined these lines, just for your own curiosity, is by being given a point and a direction. You're probably wondering what these vectors have to do with these lines, but I'll put a link below for why this vector defines this line. But you'll notice if we change the blue one now, the blue line that would be traced out by the vector here is the same as the green line. So we'd call them coincident, and rotate it might help. And so, yeah, those lines are coincident. I could have drawn the actual physical line in space, but I thought showing the trace of the line is just as effective. So they are coincident lines. All right, let's look at the next one, which is parallel and distinct. So again, this is the situation where we've defined these points in space. We've defined this line in space rather using a point and a direction. And so we get something like this. And I will show you the blue line as well, and hopefully you can start to see if I start to rotate it, that's very quick, that the blue line and the green line are parallel to one another, always. So that's pretty nifty, I think. So that's when they're parallel lines and they're distinct. Okay, next one is when they intersect at a single point. So again, have a play around here. If we move these around, these two lines, they'll be traced out by these vectors, are going to intersect at a single point. And if I show you that, you can see that it's right about there somewhere, right about there that they intersect. So if we just rotate that a bit more slowly, you can see that they intersect. So that's pretty cool. So that's the situation where they intersect once. I think you get the idea. And then finally, our last example is when they are not parallel, but they don't intersect. So that's what we call skew lines. So this line here, we sketch that out and then get the blue line. Probably looks like they intersect there, but once I rotate this, you'll see that they actually don't intersect. So just keep tracing these out, you get the idea. But as you come around to this angle, you see that they actually don't intersect and they're not clearly not parallel. So skew lines, that is what a skew line looks like. So pretty cool. What we're going to look at in other videos is how to find distances between skew lines and distances between parallel lines and all that sort of stuff. So hopefully that just gives you an introduction into the different kinds of lines you can have in 3D space. And yeah, I'll talk to you soon. Good luck.